Hi, this is Professor Cummings, and in this video, we are entering into Module 5, and we're going to go through the DMAIC process. So the various steps of the DMAIC process as far as the Six Sigma portion of Lean Six Sigma goes. So we're really into the problem-solving state of Lean Six Sigma, and we're starting off with defining the problem, or the definition stage of Lean Six Sigma. So as far as defining the problem, so this is one of the more important parts of any type of problem-solving effort or any type of troubleshooting effort. It's based off of the scientific method, the entire DMAIC process, but defining the problem is so important that even Albert Einstein made this statement. If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it. So that just gives you some sort of scope that if you don't define the problem correctly, you probably will not solve the problem, or at least not the problem that you intended to. And in some cases, you could actually make the problem worse. So that's just to give you some idea as to how important defining the problem and defining it properly can be. So what's the benefit of defining the problem, defining it properly? One, it establishes the magnitude of the problem. How big is this problem that we're really starting to address? Another is it creates a scope to your project. So exactly who all is impacted, what all should we have to do, what do we need to worry about, exactly when do we consider the problem beginning, and when does it actually end. It makes the problem easier to solve. A lot of time, a well-defined problem statement can actually give you some hint as to what it's going to take to solve the problem because of how it's worded. So again, it makes it easier to solve it. It also helps you collect your thoughts so that you are focusing on the right problem. It helps rally resources, meaning that once you see the problem, you see the scope of it, and you see what all is being affected by this problem, you now can try and attribute enough time, money, and people to the problem. You don't want to have a problem that's so big and then you don't fund it properly, or even give yourself enough time to actually address the problem, or under the right kind of scheduling. A good problem statement also will define success. It's easy to see where you're going when you actually define your problem properly. A poorly defined problem statement is subject to something known as scope creep, meaning that you start to rationalize more and more and more things on top of this problem that avoids or keeps you from reaching something that would be considered success. In other words, when are you done? When are you done addressing this problem? So you have a way of defining a successful problem. Now, keep these 5 points in mind because they're going to come up later in the presentation. So again, define the problem. There's several stages to this defining the problem, especially in the Lean Six Sigma scope of things. So the first, and we went through these stages, one is training, getting the entire organization trained in the concept of Lean Six Sigma, as well as establishing how Lean Six Sigma is organized. Again, that includes your cross-functional team, the roles and goals of each of the team members, such as the black belt, the green belt, all of the people in it, as well as understanding what the voice of the customer is. So getting everyone trained, getting everybody to understand the rules of the game, if you will, as well as organizing everyone so that they know what they're supposed to do, what the team is there for, and what the whole intent behind Lean Six Sigma are. It's definitely one of the key things that you would have to do. I guess you could say this is in pre-defining the problem. So even before you start defining the problem, the next is trying to understand the process as well as addressing any waste. So before you can really start to solve any problem, you need to know where you are. You need to know where your process is, what it's supposed to do, and what it's actually doing, what your current state is. And when you try and address your current state, there's certain things that are going to obviously show up as waste. And you can do this through a value stream map, which we understood from Module 2, and we touched on a little in one, but really we discussed it in Module 2, as well as just understanding the whole concept of lean. Some things that once you do your value stream map, a lot of your waste jumps out at you. It actually becomes just way more apparent and can be solved right away. Not all waste is that you're fortunate enough to have that, step out to you, but sometimes with things like 5S, where you can actually start to see how you can, eliminate a lot of waste in the process. This stage of Lean Six Sigma can help you as far as closing in on problems. And then the next stage is actually establishing the problems themselves. Now, here's where things get a little bit fuzzy. Usually Lean Six Sigma is brought about or motivated for a reason. There's a reason people want to go into Lean Six Sigma. It may be an actual problem. It may be established by the voice of a customer. But also it could be something that once Lean Six Sigma is established, you've got a team together that can actually address problems as they come up. So again, I'm just putting this last as far as establishing problems, what the problems actually are, which usually tie back to the voice of the customer. And also, and this is something that's very important, understanding the impact of those problems. Problems don't just exist in a vacuum. They don't just exist without consequence. Usually if you have a problem, that problem comes from, you're not meeting deadlines, a time issue. You're spending too much money, you're losing money, a cost issue. You're not giving the customer what they're asking for physically, in terms of quality, or you're giving your customer what they're asking for, but the experience is non-beneficial to your company, even within, your internal or external customers. And the way to try to understand, the actual problem as you approach them is through things such as the fishbone diagram, control charts, Pareto analysis, and other tools that we discussed in Module 3. Or, and again, Module 3 again wasn't totally comprehensive, but, we did go over some of the ways that problems were actually established and how to try and understand them and put numbers to them. Now, keep in mind what Lean Six Sigma is. It's a data-driven process. It's also based off of a large degree what the voice of the customer is. You have to understand the basic fundamental process in front of you. In other words, you need to understand the current state of where you are through a value stream map, and then you need some way to actually figure out which problems you're going to address and how big of a problem they are, which comes down to how you actually prioritize them. Again, understanding the magnitude of the problem and the overall impact of the problem. So these are all things that kind of go into pre-establishing or the pre-definition of the problem. You can't define a problem properly unless you've established these stages of within Lean Six Sigma. Now, one slide that come up throughout this entire course is Kaizen, which just means change for the better, and this is a more detailed insight into a Kaizen event. What we're going to be discussing. So solving a problem is part of a Kaizen. Now, back to defining the problem. Again, these are those 5 points that you brought up earlier. You want to establish the magnitude of the problem, create the scope to the project. It helps make the problem easier to solve, helps rally resources, and it also defines success. There is something in the problem-solving process that covers all of this, and it is a tool that's going to be very important for you if you're doing Lean Six Sigma or any type of continuous improvement, but this is very crucial in Lean Six Sigma, and it's something known as a charter. What a charter does is it kind of lays down the ground rules. It gives you a structure to how you solve your problem, but beyond defining what the problem is, it lets you know everything this problem is going to entail and encompass. Again, it's the scope, success, roles and goals, as well as the overall impact. So a team charter is a document that is developed in a group setting that clarifies team direction while establishing boundaries. Again, you can take that to say, you're defining your success, you're rallying your resources, and you need a cross-functional team to actually do this. It is developed early during the forming of the team. So again, this is one of the first things that are beyond after the Gemba walk that your team will actually do, or sometime around the Gemba walk, which your cross-functional team will establish. It will establish a team charter for defining problems. The charter should be developed in a group session, meaning everyone is there, to encourage understanding and buy-in. So again, along with the Gemba walk, along with the training, having a team charter is a way to keep the Lean Six Sigma process cohesive. So again, here's our team charter, the definition from the last slide, and here it is a template, just a random template, generic template for a project charter. So as you can see here, you do include a project name, some sort of description of the project. What are you actually doing? Who the manager is, who the project sponsor is, the date it was approved in signature, the business case. Again, you're establishing boundaries, and you're saying, what's going to be the major impact of this problem, and who's all going to be affected, all those things about it, as well as what the overall impact to the company is of solving that problem. So you're putting a dollar amount. You're, again, data-driven process. And you got team members and milestones, as well as expected goals and deliverables. And all of these things translate into different things that we learned throughout Lean Six Sigma. So a lot of these things have to be established early before you can even get to the point where you're solving problems with Lean Six Sigma. You need to know what the process is. You need to know what issues you're addressing. You also need to understand the roles and goals of everyone, as well as understanding what the voice of the customer is and what the benefit of solving that problem would be for the voice of the customer. So you need to know what the customer wants and how far you are away from giving them what they want. And that's one of the good things about establishing your problem through a problem charter. So it keeps you focused on the voice of the customer, and it lets you know exactly how you're going to address it, who's going to address it, and the scope, helps you define successes when it was addressed well. So again, there's your team charter, and what this helps you do, it helps you understand the current state, as well as who's on the team and what your current value stream map looks like. It helps you understand the voice of the customer, it's captured in the language there, as well as it helps you move to a more data-driven process, the whole Lean Six Sigma process, more data-driven. So you're not dealing with things such as just what is the most annoying, what is the most high profile, what has gotten the most rumor mill driven. Instead, you're actually understanding it based on data, quantifiable, measurable data that will help you direct you in solving your problems. So let's look at this example. This is an example we looked at a few modules ago, and it's actually, kind of an interesting example. We've got some numbers behind it. So we got this Colin Blow, this fictitious company that makes cereal. They have a product line called Colin Blow. The customers were complaining about the irregular weight of the boxes. They were supposed to be 16 ounces, and they're seeing them come in anywhere between 18 and 14 ounces. So, this is something that the customer has, in this hypothetical, have been complaining about. And we went through the data, and what we saw was, we knew there was a wide range from 14 to 18 and everything in between. We figured out the mean was 16.26 ounces, mode and medium both 16 ounces. We had a standard deviation of 1.22. We had a data, we observed, decided to do a study and took 72 samples of different boxes, measured them. You found 24 defects. Again, these are the ones that were outside of our range. And we have defects per unit at 0.33, and so we calculated out that the defects per million were 333. So roughly, not roughly, but exactly 1/3 of our product was not meeting customer expectations. Now what we had found was that the industry range was between 14.8 and 17.2 ounces. So even though we were hitting close to the target, 16.26 or 16.23, and that's like we were supposed to, our range was just too wide. We were clearly outside of this 14.8 and 17.2. We were at 14 to 18, so we were outside of that range. So our standard deviation was obviously too high. What we found with where our current state is here. We're actually dealing with 2 sigma. So roughly 1/3 keeps you at the 2 sigma level. Where we want to be, out of 1 million boxes, we want to see only 3.4 defects. And to put this more in the whole idea of Six Sigma, or mathematically looking at a histogram, if we were just to take this as representing the ideal process, where the average is 16, and the lower and upper ranges were 14.8 and 17.2, in other words, matching what the industry range should be, we would find that this, range could be achieved with Six Sigma, and that our customers see virtually no defects. There would just be just 3.4 errant defects that are escaping the customer, and we are far from that as it currently stands. So let's continue on. How will we deal with this with a company if we're trying to apply Six Sigma, a Lean Six Sigma, to this entire process? So again, trying to define what the problem is. We need to, number one, understand that current state. We also need to understand what the voice of the customer was, as well as what the current state, some data by the current state, so we can understand what we're actually talking to, what we're actually dealing with. So again, the current state, the customer's receiving either too much or too little cereal. So anywhere between 14 to 18 ounces instead of the 14.8 to 17.2 ounces, with an average at 16. So we know that that's the current state of affairs. We also know the voice of the customer, or the industry range, is between 14.8 to 17.2. And we do have data that's telling us exactly where we're at. Okay, so we know that we're making 1/3 of these are falling outside of our range. We're only operating on a 2 sigma, so we're not satisfying the customer as much as we could. So in establishing how to define this problem, we can pretty well look at it through that lens. So if we were to put this and try and articulate this problem, we could say that the customers are complaining that the weight of the product is inconsistent, and the current product has a range of 14.8 ounces and a standard deviation of 1.22. Okay, and Colin Blow is currently creating a 3.33 defects per unit, so 1/3 of our product is defective, and the product outside of an acceptable weight range are leaving the facility, which really sums up the problem well. So it's not simply the fact that we're packing boxes with too little and too much cereal, but it's also the fact that they're getting out of the facility. So there's several little stages to this problem if we really want to break it down and understand what's going on in our facility. So by doing that, we've established the magnitude of the problem. We've created some type of a scope to the project. We've made the problem at least a little easier to solve, so we're not chasing around a bunch of red herrings. You're trying to rally some resources, and we have implied, some success. So we understand the current state, and later we can start looking at the process, and then we can consider, exactly how we can narrow down this process later on. Okay, so this is Professor Cummings, and this was the definition of the problem stage of the DMAIC process, or the define phase. Thanks for watching, and in future videos we'll go through the other stages of the DMAIC process. Thanks a lot.